Welcome people. This is a little video on Max MSP techniques for creating a generative soundscape. So we will be focusing on essentially two things. One is spots that are generatively triggered, which means they occur at typically random times or somewhat randomized time instances, and loops of background sounds, ambiences, which I will call beds, that will be also looped in a way that the looping is more or less seamless. Okay, so first up we're gonna look at spots, so short isolated sounds and triggering those. So in Max MSP, to make this easy, what I recommend is that you put all your audio files in the folder where this very Max patch is located. So I have this Genscape folder, I have my Genscape Max patch, and then in here I have a set of files. So the ones that are numbered will be my spots. So I have these car spots. Well, I said isolated spots. These are not necessarily isolated. They're kind of edited out of street recording. But never mind that. Obviously, it's more about techniques than the sounds here. And I have these dripping noises. And then I will have a transition sound. Someone coming through a gate, and then I will have a few beds. So that's a market, kind of a street and beach, and kind of a, I think this is a foreign stable with some lorry reversing. Okay, so first thing to do is to create buffers for these things. So a buffer is an object that will load the sound file, and it has a unique name. So you see I've typed in the object name, spacebar, and now come the arguments, and these are the possible arguments. So first is the name of this buffer, which I will be referring to when I want to play it back. And it has to be a unique name. So let's start with dripping. So I'll have drip1. Was that a WAV or an MP3? It was an MP3. So I have a drip1. So sorry, first the name. So I'll have d1 will be my buffer name, and the file name is drip1.mp3. So you can keep looking at the Max window. This is some previous error messages. And then if you instantiate such an object, there are no errors, and also if you double click it, it should be there. Kind of displays the audio buffer contents. You also see it's a stereo file, and well, you can kind of gauge the duration, something more than a second. Cool. If it doesn't load, by the way, if this is an illegal syntax, then you see it can't open it there, and this opens as an empty thing. So the first thing to make sure is that you load your files, and then obviously they have to be in the same folder. There are different ways, but this is the most straightforward automatic way of doing it. Okay, so I have a drip buffer, and then a d1 buffer to be accurate. And then in order to play it back, I can use the play tilde object. And then the first argument is the buffer name. This is my d1. And the number of output channels. This is a stereo file, so there are 2 output channels. Okay, so this is my play object. Then I typically use a max for live gain, live.gain, which allows me to view the amplitude and also change it. And it's a stereo thing, so I can put the 2 stereo channels there, 2 audio channels coming out. And then in order to play back this buffer, I need to send it a message 1. So the toggle will send messages 0 and 1. There it was. I could say that this is a slightly soft recording. If this is not enough gain boost, I believe you can actually change that here as well. Let's see, here it is, range. So I can go to plus 30 dB. It's not great because the whole range is squeezed in here, but it does work. It's probably a bit loud. Okay, so that's my first buffer playing. And then in order to meaningfully randomize these things, in this case I want to create kind of a dripping sound, kind of continuous dripping. And for that I have 3 different drips, which are slightly different. So obviously I will need to load all of these and load all of these. So I'll do that. D2 is drip 2, D3 is drip 3. Okay, seems like they've all loaded nicely. And then I can duplicate this as well. So I'm going to be playing back all of those. They seem to be kind of matching in terms of volume, so I can send them to the same gain here. And then hopefully what I get is all 3 of them. Cool. So it's worth noting that when I send a 0 to the play object, it actually stops the playback. Only these files are so short typically that I never do the stopping. So instead of doing that, what I can do is just send an actual number 1. So each time this message is triggered, I can hear the sound. Okay, so the next thing to do in order to be able to randomize this neatly is have a way of just sending a different number for a different sound file. So what I'm looking at is a little system whereby I can click on 1, 2, 3 and get these 3 files. And in order to do that, a neat thing is a select object. I can select between 1, 2, and 3. So the left inlet is the input, the value to be tested, and then the other 3 inlets allow me to change these numbers dynamically, which I'm typically not interested in now. They're fixed. So if I do this, I have that done. Okay, I'm getting there, and then at this stage what I can do to simplify things is I can actually encapsulate the stuff that I don't need to see. And when you're encapsulating, you typically want to find places. Obviously you keep the things that are interface type out of the encapsulation. You keep the outputs out of the encapsulation. And what you normally see is that you're actually grabbing nodes where things come together and where, well, in this case also come together in a different direction. So essentially this is the bit I want to encapsulate. There is a command here, Command Shift E, encapsulate, which will then create a neat little encapsulation, and I can call it something like drips. Okay, so make sure that you don't erase the letter P and the space bar, because then you're changing the name of the object. This object is actually patcher object. This is the abbreviation. And if you change the name of the object, then the thing stops functioning. So this is my dripping. Cool. So now what I need to do in order to make this a believable dripping is to have a triggering system which is pretty regular. So let's start with just a totally regular system. We have a metronome object, which will send bangs at certain intervals, which are specified as the first argument in milliseconds. Let's have a drip every second, kind of a clock drip. Metronome needs to be turned off with a message 1, and then when it's on, did I just say off? Then it's going to be sending these bangs. So now I want to use this bang to trigger one of these things. Well, initially, first of all, let me just do a counter up to 2. And if I keep banging this counter, what I get is numbers 0, 1, 2, and 0, 1, 2. Okay, and then obviously I need 1, 2, 3 here. So I can add 1, and this will do these things. Okay, so that's fair. One thing I can do here is try to omit repetition. I could actually try to randomize it such that sometimes after 1 comes 2, sometimes after 1 comes 3, after 2 sometimes 1, sometimes 3, and after 3 sometimes 1, sometimes 2. Now there's many ways of doing this. I would essentially be looking at randomizing with some control of sequence. And in order to do that, well, one thing that people normally use to avoid repetition is earn. Now with the earn, the issue is that it actually can have a repetition. The way earn functions is it spits out all the numbers, in this case 10 of them, and then it's empty, and then it bangs on the right outlet. So what you can typically do is feed that bang into the clear message, and then every time it ends, it starts again. And then it may be so that the last element by chance is the first element in the next run. And with 3 elements here, it is actually quite likely that that will occur. In fact, can I calculate this? 1 in 3, 1 in 3, probably 1 in 9 times is the probability for a repetition. Is that fine? Well, you've seen this one. Let me then introduce the Markov chains, which allow you to actually specify the likelihood of every next occurrence based on the previous occurrence. So earn is a nice technique, and prob is the object that implements a Markov chain. So what you need to do is you need to specify the likelihood of transition from the first element to the second element, and the third value here is the likelihood. So the way I can do this is I can say 1 to 2 has likelihood of 1, 1 to 3 has a likelihood of 1, then 2 to 1 has a likelihood of 1, 2 to 3 has a likelihood of 1, and then 3 to 2 to 1, sorry, has a likelihood of 1, and 3 to 2 also has a likelihood of 1. So if I send all of this data into the prob, what I'll also do is I will do a load bang here, because I want these loading automatically. Let me just see, make sure that the bang comes through before I do this. Useful to make sure stuff happens before you rely on it in max MSP. Yeah, it does come through. And then I can trigger all these messages to set up what we call the transition table. There we go. And then once that is set up, I can typically just bang away. And let's just verify that that's doing what we expect it to do. So print those things out. Probably need to start it off with a number. Start with number 1, prob, hello. Looks like I'm missing something here. A bit of debugging demonstration. Dump, choose a new state. Funny. And if I dump it, well, that's one thing when the help file doesn't even work. Okay, let's set the probabilities. Oh, help file does work. So I'm not quite sure this load bang, did that come through? Should have done. Oh, bloody hell, that's the problem. I was looking at the inspector, not at the max window. Good. So that was always working actually, just the display of it was flawed. So what I'm trying to verify here is that there is no repetition. And indeed, there's totally no repetition whatsoever at all. Cool, so that's a small Markov chain there, which can be more useful in different complex tasks. So now I can use this number as well to trigger the drips. And obviously that's quite a lot of dripping. So actually I really wonder, I'm trying to make this such that it runs immediately as well. What I'm gonna do is save this and then I'm gonna open it again just to see if I can actually start banging it immediately. I'm gonna do that later. Yeah, so I can actually, it's a reset safe patch. Okay, so what I'm doing then is, instead of counter to go through the sequence of the samples, what I'm gonna do is I'm going to use the Markov chain to do that. And here it is. Okay, so these are my kind of testing 1, 2, 3s. And I've just reloaded the patch. It's actually worth doing if you want to create something that loads and runs immediately. So I'm just going to remove these. I like to keep my patches neat. And then I can encapsulate this bit, because this bit is now my Markov chain that omits repetition. So now the things are quite neat and clear. I just almost something wrong here. Debugging. Does the bang happen? Does happen. Do the Markov chains output stuff? They don't. Okay, so that's an issue because this encapsulation has not run the load bang as I've encapsulated it, which I would consider a bug, but support colleagues would probably tell you it's a feature. But if I reload it again, sorry for that, now it does play. It's just because the Markov load bang didn't happen upon encapsulation. So that's a funny thing, because what happens is that when you encapsulate, the objects are reloaded. So these messages did not come through, but the load bang doesn't run. There you go. Cool. So I have this dripping happening without repetition. And then, well, how believable this is, I mean, probably you can do a better job if you have multiple, more samples there. But what I will do, as a matter of showing you a technique, is randomize the timing, but just a slight bit. Okay, so every time this metro bangs, what I will take a random value up to 200. Then what I want to do is I want to randomize the 1000, and I want it to go between 900 and 1100. So in order to get that number, I add 900. Verify I'm doing the right thing. Just zoom in so you can see better. And then I can use that number to slightly randomize that. I'm not sure if I can hear it, to be honest. Anyhow. Okay, so and then finally, in order to make this potentially useful for other spots as well, what I can do is I can try to encapsulate it such that I have two crucial controls. One would be the average time, let's call it like that, average time between the drips or bangs coming out, and I will have the time, just the variation of time. Okay, so what I can do then is think about this in terms of making a randomization on both times, but I can make it easier on myself. Let's do this. I'll just have a minimum time instead, because if I do that, then my minimum time is actually the offset, so 900 in this case, and my variation will be this value here, the random range. And then I can take these, encapsulate those, and call this something like randomized metro. Okay, and then I can actually play with these things. So I can have a minimum time of, let's have a faster dripping, 400 with variation of 200. Well, obviously there's only a few sounds there, so it sounds a bit like an odd composition rather than a believable dripping noise. But I could do a few things to make this more believable. So I'll show you one technique like this, maybe two. I'm not sure if they have a pitch shift. Yeah, there is a pitch shift. So what I can try to do is pitch shift each of the drips randomly, so they sound slightly different. Now this is a stereo file, so I will need two pitch shifters. This video is mono, so you don't quite get that, but I have two pitch shifters now, and then what I'm doing is for every metronome bang, so for every new drip, I need to pick a new value here. So this will be a pitch shift factor, and I believe it is, oh, it can do multiple channels. That's neat. So transposition, pitch shift sent. Okay, so it looks like it wants a pitch shift in sense. I'm just finding this right now out because I never really used it. Original signal channel 1, channel 2, although it does send a pitch shift there. Well, that's why help files are really cool, because you can try things out. So this is a transposition in sense. Okay, so because the message is pitch shift sense, but I believe that this pitch shift factor should center around 1. So 1 should be a normal playback. Doesn't understand float. Okay, because it wants a signal. Great. So what I can do is make a signal out of a float. Here is a signal, here is a float. So my intuition thought that it would be 1 for normal playback, 2 for an octave up. and 0.5 for the octave down, which seems to be the case. Okay, so I can indeed use a single one with 2 channels. Let's do that. And then what I need is a random value. So the random object gives us integers only, and between 0 and whatever you specify. So let's take 100. And then we will have to scale and offset it to give us the range that we want. In this case, let's just opt for dividing that by 100. So I get 0 to 1. In fact, by 1,000, I want 0 to 0.1. Double check that. Okay, and then to that I can add a 0.9. Let's take by 500, and then it will be range 0.2, and then I expect to get numbers between 0.9 and 1.1. There they are. Cool. And then I can use this to slightly pitch shift each of the playbacks once I make it a signal. Okay, and let's see what that does. Okay, getting there. It's a bit frequent now. I can still hear the repetitions, so what I'll try to do is, let's increase this range. I'll go 250 and plus 0.4. By the way, I'm kind of linearly randomizing this, whereas this is not, sorry, 0.8. Linear scale. I should do an exponential in order to get it evenly down and up, but I'm not horribly fussed. Okay, I can decrease this variation. I'm kind of tuning it to what I expect to hear, and I must say that it feels like I can be even more radical here. I still don't hear it as an unnatural pitch shifted sound. There we go. I did hear it slightly unnatural, but it's probably going to be masked away anyway. So that's my second, third, fourth encapsulation, which will be called something like pitch randomization. And keep this one word and omit mistakes. Okay. Starting to get there. Okay, I think I'll finish this in terms of, obviously I could have created a set of parameters for this randomization and all the rest. Sounds good. Cool, so what I'll do then is I'll just add in what am I adding in? I'm adding in the pattern because what I want is I want an auto pattern because I want to save the data. So how did this work? I'm trying to remember. I think actually pattern, let's see. Not what I'm looking for. Let's do a preset box. Preset box is cool because it allows you to compare settings as well. So with the preset box, what I can do is I can save all the values that I've set in the patch. So I have this amount of settings, however many you need, and then with a shift click into the pattern, I can save these values, the ones that you see here. So if I change them slightly and save them here with a shift click, then without the shift I can actually load these automatically. And what I can do is I can create load mess 1, which will load the first patcher, preset when I load the patcher. And let's try that. Okay, I've closed it. I'm trying to open it. Hello. And it did load it. What I can actually do is I can have this saved as well, the fact that it's running. So you see if I open it now. Oh, no, that didn't save. Anyhow, if I wanted to run as well, what I can do is I can load mess this one as well. Sorry, making a mess. Okay, so this is my patterning, and then this is saved. Let's try this again. Load, and now it plays as soon as I load it. Great. So that's this type of randomization, and then obviously there's a few other things you can come up with. Actually, I think I'll omit dealing with the cars now because it's the same process really. So the next thing I will do, well, first of all, I will try to encapsulate this. So this is, well, you know what? I mean, it's actually neatly encapsulated. I could try to encapsulate this as well, but it doesn't really make a huge difference, I think, because this is already quite well done, because I can read it. I kind of get it. Okay, first I have a randomized metro, go into Markov chain, then I have the drips, and I have pitch randomization. Then it comes out, and you also see that here it's audio signals coming through, here it's just messages. So this is actually a fairly neat top level structure. Okay, so the next thing I will show you then is dealing with beds, randomized looping of the beds. So for that I have prepared a bed loop thing, and what it does, it essentially plays back a stereo file in this case in a way that each time it loops there is a little crossfade section. So what you can see here, let's now listen to this one as well. What you can see, actually I will let's do a shorter duration. So this is in milliseconds, right? Start time duration, it's visible. And then fade time. So let's have a fairly long fade time. So what you see is that now left one is playing, and then there is a time when they crossfade. And that's the point here. It's a kind of a crossfaded looping system, which makes the loop slightly more seamless, hopefully, or at least the transition between the end and the beginning. So what I suggest is let's listen to the fade curve. I kind of have a sensation of it dipping in the middle. It's not huge, but if I play with the fade curve, listen to how it crossfades. You see, that's a more radical dip there. And there it's a slight bulge, but very slight. I kind of go with that one. Okay, so now I can increase the duration. I believe this file is about 15 seconds. Try to follow what's happening. And then what I can also do is try to exclude the lorry reversing alarm and the funny tick. So if I start later, kind of got still the end of it a bit later. Still got the end of the lorry, so just a bit later. And obviously the tick is somewhere. There's actually only a short part of this is usable. Let's try this. When you change the numbers, it actually takes a whole cycle to get the new values. Should be fine now. Oh, did I break it? That was the fade time. These things. Since I did break it, it could be actually a problematic subpatcher. Deep testing is always good. It started 0 anyway. It seemed to work. I think I've messed something up with the start time. Okay, so edit your files. Don't use the start time other than 0, and if you fix it, let me know, and I'll be ever so thankful. Okay, so that's briefly the operation of the bed loop. I won't go into explaining this. It would be a kind of a long video, but instead what I'll get into is transitioning between different beds. Okay, so I have the environment 1, which is ambience, and then I'll have 1, 2, 3 more. So I have a beach. Was that MP3? So my environment 2 will be beach MP3. And then I have market MP3, so that's my environment 3, market MP3, and my environment 4 will be street.wav. Okay, and then what I can do, obviously double check, have these things loaded, looks good so far. And then what I can do is duplicate this a few times, 4 times in total, and change the buffer names. So this is env1, this will be env2, env3. Although, let me just duplicate this together with the gain stage, because I really want to be able to control those separately at this stage. So we have the 4 environments, and it looks like they're already neatly playing back. Let's hook them up. This is my beach. This will be my and then this will be awesome. And then obviously what I could do is just set these up nicely. I won't spend the time now, just whatever seems feasible. Maybe I should fix the start time thing, huh? It's a good challenge. Those things could be... sorry, start time. Shouldn't have done that. Let's fix this start time, okay? Let's be nice and neat. I really wonder. So what I have here is zb.bedloop, which is an encapsulation but it's not a patcher. So what you see here is that it's an encapsulation that contains the stuff, and if I duplicate it and remove something, I haven't affected the other one. You see? So they're kind of independent, these two things. Whereas if I save a patcher, which has inlets and outlets, these things, as an external file and then load it, then changing one will change all of them. So that's the other way of encapsulating stuff. And this is the case here. So, and what you will notice is that actually this is a non-editable display thing, just because it's actually an external file. So I'll load this. Cool. So let's see what could be wrong here. Oh God, I'm really opening it up now. But let's investigate the one that is actually running. So what I expect here is that something happens, starts at 0, runs for this duration of time, and has a fade of 0.6 seconds and the curve. So something wrong with the math here, obviously. So what I'm doing here, let's first investigate that. What I'm doing here is I am taking these values into the play stereo. Now it could be that the play stereo is problematic, but actually it's more likely that my math here is problematic. So if I was to be very meticulous, I would probably verify this as well. So it prepends start. So what's happening here, let's just see. So first of all, the curve is there. Don't need to worry about that. This is my fade time, which is 682. I double that and I subtract it from the duration. And then from that I subtract the start time, and this becomes my sustain time in the envelope. I'm actually curious whether that does work, because if I double that, I might not be counting for the doubling here. Let's see. This is slightly more complex, but if I double that, yeah, subtract it from the duration, this should be the total duration, right? So my total duration is supposedly 5.5 seconds, and this looks good here because my final envelope is exactly that, and my start time should be fine. So I reckon that the play stereo is fine. So it should be some kind of math problem here. So what I'm doing here then is I am triggering the metronome. Well, actually I probably can guess it already, because what you've had is that when I increased the start time, then the metronome was running too slow because I had gaps. So what I'm doing here is I'm subtracting the fade time. Oh well, unpack 0 start time, duration fade time. Yeah, so my metronome is running at this rate. Which should be fine actually. It is just that, let's see what actually happens with the numbers when I increase the start time. Let's make it 3000. Okay, so the play stereo. Yeah, so it's obviously in the play stereo because it doesn't play through. Could it be the duration of the sound file? Yeah, it's seems like it's an issue here. So I've sent it to 3000, 5000 there. I'm subtracting the start time for the sustain, and that's the wrong thing to do. You see? So this is my sustain time, the 1000, and it's gone down as I've increased the start time. So I believe that's the bug. So I'll just remove that in the original one. So let's save this, close that, open this, play stereo. That's an error. I shouldn't be subtracting the start time there, because the sustained duration is not dependent on the start time. That was a silly mistake. So, and then I can copy this, past replace it there. Oops, wow. Copy, did I forget the past to replace? Okay, double check, looking better. Looking better. Okay, save that, close that. Here we go. So the duration is something, fade time is something or other, and then fade curve. Okay, is that fairly seamless? Looks like we're crossfading neatly. Yeah, and then the test, I'm increasing the start time. Yes. Woohoo! Okay, I fixed that, so I will update the ZB bed loop with the new version. Probably put it in the comments of this video as well. Sweet. Well, one thing I didn't do is I didn't save this. I mean, I spent some time setting it up. Unfortunately, didn't save it. But it should have saved. I mean, I could have saved it. Sorry. So I'm shift clicking the preset box. Save that. Let's open it again. Those ones were saved at least. Okay. Well, we'll stop this and just get some values in here. I won't spend the time now. Just so we have a running thing here. And then the one last thing I will show you is first the transitioning between these using a nodes object. Okay, does this one play, plays. Okay, so the nodes object is neat because you can do a really nice navigatable soundscape with it by essentially creating a transition between different things. So I actually recommend getting this one to start with. It already has this is the help file. It has a little navigation cross there, and then what you get is a distance from all the circle centers in relation to this circle of attraction. So if I'm at bang in the middle of 9, that's full on, which is value 1, and I actually get distance to all the circles. So I'll be using this one to start with, but first I'll set it up so it works with 4 different locations. I don't have 9. So in the inspector I can set many things. Knob size, font size, number of nodes. Okay, I'll do 4. And then I can drag them around. With Alt click I can increase the size of the circle. So what I'll do is I'll have them kind of spread out a bit. 1, 2, 3. I'm not really fussed about accuracy at this stage. Let's say this is my soundscape field. And then what this nodes object does is it sends out a list of values which represent the distance to each corner. So actually I don't have a total silence anywhere here. kind of hear all 4. No, actually I hear 2 here. Doesn't really matter for me at this stage. So what I'm interested in is changing the gain of these beds based on these values. So what I first do is I unpack those 4 floating point values. Unpack. That's great. I didn't make silly jokes in this video. I'm very determined. And then what I'd like to do is change the gain of these things. Well, actually, I could use these as well. This can change the value in dB. Let's just double check that. So I think it will. So I can try to do that. Actually, let's keep these to control the maximum volume, and let's use separate gain stages for our bit. Okay, so a gain stage is a multiplier. These are stereo files, so I'll need 2 multipliers for each of these. Okay, whole lot of patching coming up here. So a gain stage, and then into the speaker. And then let's do this for all of them first. So each one will have an extra gain stage. Okay, now you can take a deep breath. Always remember to meditate a bit during the day. Make sure your eyelids are relaxed, unlike mine when I'm doing something. Too much tension around the eyes causes problems in the long run, which I'm already having. Okay, gain stage for each one of these. Now, none of these will play currently, just because this gain value is now 0. And actually, that's about it as well, because now I control the gain of this. Each one of these from each of the node distances. Okay, and then the final one. Is there. So now if I actually, as I wanted to use the, let's try to make this neat to an extent. So what I'm said is that this will be my maximum volumes, which I believe will save with the preset. So actually before you exit the patch, unlike me, best is if you always shift click in order to save your presets. And now I should be able to kind of walk around. This is now number 4. So this one, the duration is just too short. And most of these are 15 seconds long. Generous in the durations. Okay, so that's some bad transition. Obviously you can change the size of the circles and all the rest to make it sound better. And here's my dripping. Ha, that's lovely. Okay, we're almost there. So the one last thing I'm gonna show you is a transition sound. So let's first of all see, is there, because you see I have this gate sound here. So what I can do is I can try to play that sound when I go from one, or actually when I enter one of these fields. So which one could have it? Ambient. Well, actually, it's all outdoors, really. If I go to, well, let's just listen to it and imagine. Let's say I want the gate when I enter the forest, because all the rest is kind of city-like. So what I'm looking at then is the distance to the forest node, and what I want is a trigger when this goes from 0 to positive. Okay, so what I can do is first of all say, is this larger than 0? And then this one should yield a 1 and a 0. 1 is true, 0 is false. So it is true when I'm inside. But what I actually want is just a single trigger when I go inside. I have a single gate sound, so if I had to, I'd probably make one for the getting in, one for the getting out of it. But in this case, sorry. In this case, I just want a bang for transition from 0 to non-zero. So this will be my bang. And you see it neatly happens only when I get in there. Okay, so in order to do that, I'm gonna do a buffer G1, which will be my gate. Was it an AIFF? Something like that? Yep. And then what I want to do is I want to play the G1 file, and in order to do that I need to send it message 1, and just not to have too many chords spreading around. Let's do it like this, and there it is. So I'm getting out, it's not playing. I'm getting back in, it's playing. And then I can just neatly encapsulate this as well and say this is my gate. Okay guys, well that's it. That's what you can call a generative soundscape. And I'll leave it at that. Save this. Thank you for watching. Bye.